like I said, the second pain point is HTTPS.
Mm-hmm.
I think it's important to have it done once at least in your lifetime. Kind of like to have a Python API hosted on a little machine, maybe a Raspberry Pi or something. And then on top of it, really having to configure HTTPS, usually either with Nginx or Apache. But I really don't recommend Apache for the reason that
It's big.
nowadays everyone uses Nginx.
Okay.
Like it's just much faster, much simpler, much more straightforward. It was a huge like it changed so much in the industry when it came out. So you definitely want to go for Nginx if you can. Yeah. Okay. Want to dive into code? Okay. So the first and most important ones is you need to have a framework for writing, and you need to have something serving that framework. And I really recommend to you just go with Fast API and Uvicorn. You will never hit like it's just perfect combination. Don't think about it even too much. There's Flask, maybe a bit older something than Fast API, but generally Fast API is really it's literally fast for Python, and it has a utility that is beyond beautiful, man. Like it's super. It's really nice. So working with it is it's really heartwarming. Yeah, so don't think about it. Fast API is just for building the API. You need to serve it still like a web server and that stuff. That's Uvicorn. Just that you understand that this is just for building the API, but it cannot serve itself. That you need to have the serving layer on top of it, and that's from Uvicorn done. Pretty normal. It's also good because you could exchange the serving with something more efficient maybe in the future, whatever. So it makes sense to really separate those layers. When it comes to coding, I try to violate one of the rules of statelessness here to demonstrate a database. I really wanted to not just give you anything, but I really wanted to show you how it would look like if you would have a database, you know, and how to work with that in an API. And this is also where it comes a bit from the last exercise you had into the game with polymorphism, what I was showing. So what you usually have is, if you have a database somewhere, whatever that kind of is, you have an abstract class for the database where you just implement the methods as abstract methods. Okay, so it's really just an interface definition here. Okay, and then you have a specific implementation of that in your code. And the reason why you want to do that is you never know if you're gonna migrate. Okay. So in case you ever migrate to another database or interface a second one with the same interface, you know, you could even have them in parallel working to check them out. It's really useful to have this abstraction. And also very important is these types which you return should be under your control. This should not be something database specific. This is really the lesson if you have a database in your API. Here a planet, I defined that, is just name string, so there's nothing in, but there could be 5-6 attributes. Here's one of the most important things. We use Pydantic base model here. So you see there's a base class. And why is this important? Because through this base model class, Fast API can serialize and deserialize JSON coming into classes automatically. You don't have to care about it. So they take care of that entire shenanigans, which is usually a huge effort in many languages of deserializing and serializing payloads. It's already done with this one here, Pydantic. Amazing. You know, really amazing what they did there. Has a lot of options. Like here, I didn't use too much of it, but Pydantic is really amazing. That's why I love this Fast API so much, because it's deeply integrated with a lot of things which make sense. For example, this one, you could also, the base model, you can works well with SQL databases, so you can also set up queries. What you get back from the SQL database is not some tabular data oddly in a dictionary or so, but also a class. It's super. So this is why this Pydantic is so important, because usually it's not only for deserializing what comes from the database in and out, but from the network from the client, but also sometimes from the database. So this really makes your life easy. Yeah. Here what I do is I instantiate actually a fake database with multiple planets, just that you know.
Okay.
You see it's just key value, whatever dictionary, which would be like usually in a database you have an ID, which is here the name, and then the instance itself, which has the name again. It's a bit without fun, but who cares, you know? I just wanted some kind of database or some data. So that's why it's a fake database. And then I just implement those methods, and then I'm done. You know, how to get a planet and how to remove a planet from the database.
Understood. Yeah.
And there's also two things. If you get a planet, you see I also return none if there's none. I don't raise an error or something. I really like this. There was just nothing, man. You know, because there's a difference between something went wrong, actually retrieving it, or there was just nothing there. You know.
Yeah.
Because in API, you only really need to think of it in the API is it makes a difference if it's a 500 or whatever error, a 400 something, you know?
Yes.
Because if it would be a 400, if a person requested something and it isn't there, the planet, it's a 404 not found. Yeah. But if there's an error while reading the database, it's a 500. So if you just would try catch, and because a catch is usually a 500 in the range, or it's handled automatically by the APIs as a 500. So there would be an error if I would retrieve a planet here, and there would be an exception thrown. It would automatically get a 500, which is wrong. It's a 404. So you see, here in the function signatures, actually is already some knowledge of what I told you before.
You have to think about the non-case, right? So this is,
Yeah, you need to think about what the other person, what do I need
could go wrong
to tell later. Yeah. For example, here, remove planet is very similar. If I remove a planet,
case one, it's there.
Why do I need to return a Boolean? I could just say, okay, whatever. It can never fail. If it's there, I delete it. If it's not there, I don't care. But the thing is, I still need to tell the other person if they screwed up. So I need to have some return value to know if there was actually a planet or not. Because in one case, it's a 404, you know, because then the other system might think, hey, I deleted the planet. That's right. Yeah, and continues. But that API needs to know, hey, no, there was none, 404. Yeah. So you see, if I would just write this routine, I would not return anything. I could just say remove planet and that's it. Right. But if you think about HTTP codes, behind it, you actually need to modify these signatures. So you see it's a bit, that's why I wrote this stuff above, why it's so important to know roughly the ranges and that stuff. So you can play a bit with it.
Right,
another cool things is the ABC crate, I programmed too much Rust package. In case you want to know, that's for just abstract classes and stuff, you know. So that's here, this ABC I inherit here from ABC. That just means, hey, it's abstract. Just that you know why it is like this. Python is a bit odd there because it doesn't have it natively, but whatever. It's Python.
And
we love it for being simple.
And you go for async programming. Is this required for the API?
Yeah,
or is it?
That's actually quite important because you have multiple threads on your machines. And async is basically every async function call is, you could say, like a little task. And you can think of, if you get a lot of traffic in, then you have a lot of little tasks to do and you can distribute them then nicely over the different processes. Okay. So that's why it's async, because in the background it's already handled asynchronously. Not all of them, and not all APIs are asynchronously better necessarily, but generally, yes, it's better. if you know, like if you don't screw up, and here you cannot screw up because fast API and UV code basically handle it for you most of the part. Just important is chop stuff into small pieces if you do async. If one part is big, it's not so good. So if you go async hard.
Yeah.
Okay. So now that we have the database, we need to create the API to work with the database and serve some requests. Here, it's fairly easy. You just instantiate here the fast API. You can give it a ton of attributes in here with descriptions and whatever you like, But yeah, here I didn't go for it. It's a tutorial. Look into it if you ever have a production app or something. Then you have database. We instantiate it globally here, which is pretty interesting. I don't usually like it, but like the API is instantiated globally too, so I need to put it basically next to it. Otherwise, it doesn't work. So then, yeah, a nice part about this is usually this needs to be thread safe in other programming languages, but fortunately Python is a bit dumb, so it does that for you. It's really a nightmare doing this and making sure that this database connection is used for multiple threads and stuff, and that it's safe. And wow, usually I sweat when I think about it. Now what you then basically do is you just define then functions which do your work, and on top of it you add this decorators. And they just describe basically what route it will be. It's so easy, man.
Yeah.
I mean, imagine you just do basically this, write a function, put a decorator on, and you have an HTTP endpoint. It's ridiculously nothing.
That's pretty easy, yeah.
I mean, that's so beautifully easy, and that's why I love it so much, because it's also just so clearly, nicely made. Why did I start with delete? Usually you do the get first. So this one is for deleting the planet. Important is for the path, man. Two things. /APIs anyway, you should always have a prefix. V1, you can guess why.
There will be multiple versions.
You know that after some time you figure out like, I could do it better, man. I could really do it better.
Yeah.
But then imagine what happens if you change the endpoint and 700 websites rely on you.
They will not work.
Yeah, you break a ton of systems. So that's usually why you should version. And you can always say, I moved to the new system, dudes. Like the old stuff is bad. I don't maintain it anymore. Yeah, so just that you know. Then another thing important is, in the path you should always go for resources. Like behind something here should always be a resource in your database or something. You don't go for abstract things like actions, usually like pickup or something. Like you would not have here a route pickup. You know, like you cannot avoid it always, but it's really bad design. Like behind this, you can think of these methods. You do something. They put, they post, they get, they delete. So this is already describing usually what to do with this stuff. So of course, what's important is just to describe
what stuff.
On what do you want to do. Yeah. So here should not be, again, what do I do with it? You know, here should be really on it. What is it? On what do I operate? So that's just that you understand this importance. What on what? Yeah. So that's the resource. Because I could, to destroy a planet, I wrote it in the text, I think. I could do /destroy method and do a post on it or something, you know? No, we don't do that. Like, that's not good design. You do a delete on a planet and that's it.
It is path is the path to the object in the database, right? Or is it...
Not even the database. You don't care about the database. This is just the description of the...
What this command does.
Yeah, like if there comes a request here in the URL basically with a delete, I mean this is a get, but if there would be a delete, and then in the end here there would be the planet name,
all right,
which is target.
I see.
I should have mentioned that. Yeah, and it matches this target here to this one. How nice is that, man?
Yeah.
So beautiful. And also, you see, I can give a 2 or 4 because if I destroy the planet, like there's nothing to say, you know, like it's gone, you know, if it's okay, if it's
that's where the programming humor comes in.
No comment.
Gone. Yeah.
I mean, you could do a 200 and say,
No
yeah,
payload.
ain't there anymore. but it's pretty clear that, yeah, you can just do a 204 and let it rest in peace. Yeah, it's basically like the emperor saying no comment on destroying Alderaan.
Yeah.
No, the action speaks for itself. Yeah, and also cool is here. Here, for example, you see I try to remove a planet, and here I get the success back, the Boolean, and if it's not success, I already know that, okay, the planet didn't exist, and I can give it a really nice error message back. How beautiful is that, man? You know? And you see, then I give a 4-4. Also important. So this is exactly why you need to think about in this database about what to return, so you can then properly give here the arrows. Another really cool thing is about the get request down here. It's basically the same thing with the planet. You see the route is the same. API v1 planets, and then here it's target and here it's name, whatever they don't care. But it's the same, but it's a get request. So to get a planet is something different. Yeah. So it's just a method different. And I really like that. You have a resource, you can get it, you can delete it, you can post something, you know, to maybe upload it or do a put here. Maybe a put would be more good here to upload a new planet or something. So yeah, that's quite interesting. Like I could do more routes here. I just did a get and a delete. You know how it's going.
But the get and the delete
cool
must also be in the URL then, right? So besides the path, because the path is the same with API v1 and stuff. But
it's in the header actually. In the request header, you say this is a get or this is a delete. But it does it automatically usually.
All right.
We get to that later. So so you have a response model. Which you can specify here also in this thing. And this is really cool because you can then just return this class and it's deserialized to JSON or XML or whatever by Fast API itself. This is one of the, again, amazing things. You don't have to care about transforming it yourself. This is because of Pydantic, but Pydantic converts that automatically in the type which the person wants to receive.
Wow.
Yeah, really cool, man. So you just get a planet name, you go into the database. If it ain't there, then you can say, okay, it's a 4-4 again. But if it's there, you just return the planet, man, and you're done.
Wow.
Like how freaking short is that?
It's pretty short, yeah.
Yeah, right. It's amazing. So that's why I love this Fast API setup, because you really can get stuff done so quickly. But you should really follow good designs that you don't screw up, especially in Python. Yeah. So these are a bit the more important stuff, how to do it. Unfortunately, I didn't incorporate here some Postgres or stuff because we haven't done... usually I like to combine it with Docker.
Yeah.
And Docker hasn't been there as a lesson yet. So you see kind of... Yeah, we are getting there, but this can explode a lot. Yeah. But usually there's always a database behind it. Like... In the example, the next example task we have, you won't have a database, fortunately. That's why you can rest in peace for the moment. But that's why I want to maybe add one more example where you get a database on top of the two. So you don't know how to deal with it. Yeah, just that you know. Yeah, so that's a bit some important aspects of it, you know, like the get, the delete here is basically what do you do with stuff. On what do I do it, and then some really cool features around Fast API. And there are a lot of more. Just they have a good docs. Like read through the docs. There's a lot to learn there. They really have cool stuff. Really recommend it. And exactly. That's how you run it. By the way, I incorporated it into the CLI because we already have a CLI. So what happens is if you have a complex web server, they even write a CLI for the API server to start up. So you have different options, like for example, which IP, like do you want to show it off to the internet or not, or which port, that stuff. Just that you know, and then you just run uvicorn. You see uvicorn inside, and then you give it the Fast API app and hosting data, and that's it.
Wow, it's also pretty short.
Yeah, that's super short, man, for the stuff it does. screw it, man. Typos. Let's see. I have it here under API, but you see it's just poetry run Death Star API, which is the command, and then it does it now. And you see the server's up already. And this is one of the really cool things about this API. You see I get a not found when I visit the main thing, because of course there's nothing. But what it does automatically create is this docs route.
Oh, okay.
And this is something you should also know. APIs are usually documented, or the specification is even wrote before implementing the API, which should be what you do if you design a system.
Okay.
In something called OpenAPI is a fairly good standard for it. It's basically YAML or JSON, and describes you all your API routes. It tells you the error codes which you have in your code. And the most amazing part is usually you do that manually, but Fast API creates all of this automatically for you.
Okay. Yeah.
That is absolutely ridiculous. Like,
You don't
just
want
that you
to mark
understand
that
why I love
manually.
Fast API so much. No, not all the time. You know, like sometimes you just write the API and then you get the documentation for free. And it's
helpful,
always up to date. That's super. And not even better is people can go on the docs and they see all the routes and the methods. You don't have to write the specs or something. You can just say, there are the docs, you know, this is the URL for the docs. And that's it, man.
And you can test it, right? So with the try it out feature.
Exactly. That's
nice.
That's what I wanna show. Yeah, you can just test it. For example, if I type something in which is wrong, I run it and it says here I get a 404, not found. That's correct. You know, and then like planet blah 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 does not exist. And then I can of course type one of the planets I know, and you get back actually the payload from the class. Like the class has just a field name, Alderan. So you already know
also the code.
It's correct.
Yeah, that's great.
And here you see how the route also was basically, so really nice. Doesn't, by the way, big or small here doesn't matter. It works both.
But sorry to interrupt. Here the get is not in the URL, right? So you have that in the curl command. Yeah, there it is. But in the request, there's just
it's not. It's in the header. You see the curl command. It's a curl minus x get. So minus x is basically it's in the request header. It's inside the request itself. So it's not in the path. This is the path then. And here you see also it sets the header accept, which is basically what you type to you accept as response, and here it sets application / JSON.
So, but you could not use the request URL just in your browser to get the planet. That's not possible.
Yeah, you could.
Yeah, but how can it differentiate between getting and deleting? Because the commands were the same.
Your browser can just do get.
Sure.
Your browser always does get. It never does delete.
Yes, right. Yeah.
So you see, I get if you have a get, you can really test it like this. You can go on the route and you see, okay, this is the JSON payload. It even does this nice transformation. Yeah.
You could not delete. You could get because browser is always getting. And all right.
Yeah. But I can use this one here, of course, to try deleting. Can once again type something in which doesn't exist. I get a 404, and then I can do this, and then I get back a 204. That's it.
But here the request URL cannot be used in the browser to execute a delete command, right?
Nope, no chance. You need, but what you can always do is, and that's true, you can always do a curl request. Like curl, I wrote that further down in the tutorial, but curl is really your best friend because it's everywhere.
Yeah.
So if you test anything, usually do it through a curl command on your system. Like often we need to debug systems, not even systems not in our hand. Then you usually go for a curl command. So you have, for example, you want to query the planet. You don't even need to specify the method, by the way. But it's by default a get request and you get it back, you see. So this is how you can do it. There are a lot of tools like Postman and stuff. But, oops, you see invalid HTTP request received, destroyed.
Yeah.
That's it.
Yeah. Nice.
So really, really nice. And here, by the way, you see also in the logging which requests came in. You got a get request, a delete, So it's really showing a bit.
Yeah.
Yeah. So curl is your best friend there, but this is amazing.
Yeah.
This automatic documentation with fast API.
Yeah, definitely.
Open API.
Yeah. It's great.
Yeah. Really love it.
Yeah.
Golden question to you, really devious. What endpoint would I implement to list all the planets?
What endpoint?
How would I implement that I get all the planets?
The route? Just without a target? API of v1 planets?
Which method?
Get?
Yeah. Okay. What if I have 20,000 planets in my database?
Maybe you should check the header first, right?
Nah, no.
With the payload, or what do you
that.
mean?
Yeah. What if I have 20,000 planets and someone makes a GET request? What would I do? Do you know it?
No, not really. But maybe just ask if...
What you usually...
Yeah. There's this I saw that you will get the first items, and then you will be asked if you really want to load it. Is it that?
No.
Also
what you usually do is something called paging.
Paging.
Do you know on the websites where you can always click next to show the next 20 items? That's exactly what they implement in the API.
Right, okay.
They kind of say, okay, there are 20,000 planets. We can send you maybe 30, but then, if you want to know more, then you need to ask again.
All right. It's like with the eBay, the amount of items per page. If you can change that to 50 to 100, it will just modify the number of. All right. Okay.
Yeah. That's usually the page attribute.
Yes.
Which page? Like if I have, you can, and how many items per page?
Right.
It's called here in the GitHub API.
Yeah.
It's a good example. So you can say, okay, you can have up to 100 view, for example, in GitHub.
Yes.
Default is 30.
Yeah.
But then you can say, okay, the first 100, the next 100, the next 100, until you really have it all. And that's usually a bit of pain in the butt because you need to implement the paging yourself.
Yeah.
Yeah. Welcome. And you need to implement the paging also in respect to the database.
Yeah.
I didn't do it here. Maybe it would have been good to have it as an example. I didn't think of it. But yeah, paging is something you should also know. So yeah, if we want to have like one additional routes, we would have to do the paging to get the planets, forward that to the database, and that stuff. So you see, it's a bit of pain if you do certain things.
Yeah.
Not a pain, but extra effort you need to be aware of, because you cannot send 2 megabytes of JSON payload.
Right.
That's not what you should do. Yeah, it's too slow. Yeah, so you can really run it, and it's super easy. Like I said here, you just have the command poetry run. Death Star API is basically it, and then it runs. You can curl it. There's a lot on top of it. Like integration testing is usually something where you have the API running and you want to check if all the routes are correct. And you don't do it through unit tests, because unit tests don't really do the network request. You really want to do a network request. And usually what you do is then integration tests, and what you write is either Python program which queries your API or a script or something. However you get it done, but you write down certain cases, query your API, check the cases if all is working well. So that's integration test fun. And then if you get some errors from users, you can encode it into integration tests or or unit tests, whatever you like, and have it. Like I said, the second pain point is HTTPS. I think it's important to have it done once at least in your lifetime. Kind of like to have a Python API hosted on a little machine, maybe a Raspberry Pi or something. And then on top of it, really having to configure HTTPS, usually either with Nginx or Apache. But I really don't recommend Apache for the reason that
it's big.
Nowadays everyone uses Nginx.
Okay.
Like it's just much faster, much simpler, much more straightforward. It was a huge like it changed so much in the industry when it came out. So you definitely want to go for Nginx if you can. It's really just a web server. Think of it in that way. Yeah. So, and then combining that Nginx, like I said, if you run that Let's Encrypt bot, for example, it automatically installs itself into Nginx. And then you just need to basically, for example, what you do is Nginx receives then internet traffic on port 80 or something, or 8080, whatever you want to have, or 5000. And then internally it forwards it to the port where the API runs on locally on your machine. So it's really just in the middle of handling the traffic from outside and just forwarding it, but at the same time also doing the HTTPS.
Okay, sounds super simple.
And it's quite nice because you could also install the certificates into your apps yourself. I did that also in the past, but then you have to deal with certificates, and no one wants to do that on that layer. On that layer, that's important.
Right.
Yeah. Like I said, I always rely on my Strato. Servers I always like to buy. It's so good, man. Like they cost €6 a month, and they are just ridiculous what you get for that money. I mean, I usually do the monthly build, but €6 and you get 4 gigabytes of RAM or 8 gigabytes of RAM, and then 300 to 500 gigabyte of SSD. And very important, that's usually what you don't get so easily from most providers. Unlimited traffic. Okay, throttled at 100 Mbits, but man, like 100 Mbits for an API is a ridiculous amount. So this is really the important part. Traffic unlimited. If you want to serve some traffic, because ingress and egress really cost you ridiculous amounts of money in some hosting sessions. So I really like these servers, but you cannot cancel them so easily. I think it needs to run, even if it's only 1 month, it needs to run 1 or 2 months usually. I think you always need to pay, I think, 1 month more, something really fishy they have. But I don't care. For €6, it's so good, man, to have a server running you don't need to take care of.
Right. Is it even maybe less expensive if you pay for 12 months? Because you can also go for 12 months at a time.
Yeah, I guess. But it's only €5. €1 saved, man. Like for just being able to cancel any time, I pay this €1 more if I have one of those. Yeah. But the other ones are also pretty good, I must say. Like €33 for 60 gigabytes RAM, 2 terabytes of SSD, man, 16 CPUs. This is ridiculous. Wow. And 1000 Mbit, man, 1 gigabit and unlimited traffic too. Like, this is a good deal, man.
Wow. Okay.
Only paying. Yeah. Those servers are ridiculous in the pricing compared to AWS. Also, like they're really good. I know why. Of course, they don't have service level agreements that high, I think, or stuff like that. But screw it, man. Like you can really rent good servers with them. Fortunately, this is the German one. They also have it in other countries, but the German one really saved my butt a few times when I wanted something. But just buy a Raspberry Pi, man.
Yeah, to try it out.
It's great.
It's
you don't need.
Fine.
For hosting an API, you can also do a Raspberry Pi, but then it's a bit annoying because you need to find a way to, if you want to trigger it from the internet. Right. That's the pain point then. Yeah, so it's always good to maybe just rent some server somewhere, SSH into it, configure it, and that's done. Yeah. Another thing, don't worry too much about it. Performance always too much. If you don't screw up, like there are ways to screw up even in Python, but usually, I mean, if you talk about throughput in Python, you already are not in the right place. You know,
wrong language.
Usually what they do is they, if you go in Python and building an API, you want to save on development time, which means you build it, okay, fast API goes quick, whatever, and then you want to deploy it quickly. And usually what happens is if you deploy it, for example, on a cloud service provider, whatsoever, and there's more traffic, they just spawn more in parallel. You know, and that's really how they horizontal scaling. So that's really how they deal with this pressure. So you could say, okay, of course, Python is less efficient than Rust. Yeah, it is, but we can just spawn more of those, you know. Well, you will pay more for sure, maybe a ton more, who knows, maybe not, but you can be sure that, okay, don't worry too much, as long as you stick to the REST principles, that you don't screw up somewhere. This is not a problem at all. Yeah. I mean, you could even go really fancy stuff like do expensive subroutes in the different programming languages, hosted on different servers in another language. You know, you can really, you understand,
can do that,
like,
but maybe not for the first exercise.
No.
Yeah.
But just that you understand, when you have this Nginx layer on top, this load balancer, it can really serve different services which run in different languages and do different things. And, you know,
a custom system,
Yeah, you can really, really fan it out. I mean, if you look at something like GitHub, it's really not just one service.
For sure.
You can be sure of it. Yeah. So, you know, different parts of the service are served by different teams building different routes and stuff.
Right.
Yeah. So that's a huge lesson, man. And it's nothing in it compared to other lessons. I mean, like I could explode it to the brink of existence, but I think the most important part is the important things are really in there from the names, you know, like these protocols a bit, these methods, these HTTP codes, which are really important to know and really think about them. But database handling, paging should be really added. I really feel bad for it now that I realized I missed it. And yeah, curl, big friend always, you know, standard stuff. And really, I really recommend get yourself a web server somewhere or try it. You know, get a REST API, Raspberry Pi. You can at least do it at home. Then don't need to care about internet maybe, and then just do it at home. And say I host a REST API in my own home.
Yeah, makes sense.
Yeah, you feel overwhelmed, man, right?
Yeah, it's a lot of info, and
Jesus.
And the
sun is already setting here. It's so getting dark. I forgot to put on the lights.
I saw it on the video. The thing is that it's not just much of information, but on the other hand, it's just with every information you get, you have another 10 things to put on your to-do list, because there's no end. There's no end.
It's also important that you know that, like, I can get all of this stuff roughly done myself, but if you want to do it at scale and big, you either have to pay for the cloud providers because they do it for you, or you have to hire an entire team for certain topics, just that you understand it. So and also important, even if you write just a Python API, you can be sure that you should and have to have some knowledge, not only about these HTTP methods, but also a bit about, that's what my one colleague there said once, about stuff around, you know, that there are different services connected, how is routing done, how is HTTPS done, that you just have an understanding a bit how systems are generally built. And even if other people take care of it, but I had it more than often that you have an error, and it's not even like, sometimes the ingress controller gives you an error code, not even you know. And then it's really important to know what's going on under the hood. That the Nginx was, I don't know, it's classic, like when Facebook had DNS issues. They could not resolve their routes, and Facebook was down. When you think about, okay, it's quite clear, I know it's a DNS error. You know, if you have no clue about the systems underneath, how they operate, you're screwed. You know, you search all day in your service for problems.
You're saving yourself some time when you do the error codes properly, because you can save on the debugging time when you have to debug it, to know exactly where.
All of it. But also understanding how your application really runs.
Right.
You know, maybe even if you don't host it, ask a person at your company who does, and ask them, how is it really hosted? Where are the servers?
Right.
You know, where are they standing? Literally standing. Like, for us, it always makes a big difference, because then you understand, it's this data center. Okay, that explains a bit. Somehow this data center always has odd latencies, for example. You know?
That goes much into
one
it.
data center from us. Imagine you have a Kubernetes cluster with hundreds of nodes, which are in some data centers. Nodes are just computers. And this one data center always shuts down very aggressively its nodes when they do maintenance. And it wrecks a lot of services, because they cannot shift their pods necessarily so fast as they shut down their cluster. You know, it's always good to know what's going on underneath. You know?
Right.
Yeah. Okay, it's gonna be. It was a long lesson.
1.5 hours.
I knew it already.
Yeah. But yeah.
Screw it. It's important. I mean, it's really filled to the brink with a lot of information I could put in. And maybe we will discuss and think about also whether to put more on this. Also, people out there, just let us know if you want to know more, really how to build it.
Yeah.
And if we should maybe make 1 or 2 appendixes to get deeper into this topic of building APIs. Really at the heart and the core. Yeah.
Right.
So you can also tell us.
Yeah. Do that. Leave a comment, like, subscribe for all this effort. Yeah. And then hop onto our Discord servers, and we will see you around hopefully. And I can't wait to see you next time. In this case, bye guys.
Thank you very much.
Bye bye.
Bye bye.